So we're gonna do our last class today, and then not last teaching class, and then so I just want to point out to you guys about your final. So let me share the screen to you guys. Finals. So your final is actually is 2 Wednesday from today. So 2 weeks from today, May 12th. The chapters we're gonna go over is 7, 8, 9, and 10. I want to point out that there will be no reviewing on the finals here. There will be a review, but it's not on the 12th, the 30 minutes before the finals. The review is actually on next Wednesday. So your review is actually on Wednesday, next Wednesday is May 5th. May 5th. Yep. So we do have next week, we do have a class. We have a Zoom meeting here, and that Zoom meeting is go over chapter 10 homework, because there's chapter 10 is due next Wednesday, and we will review for your finals here on Wednesday. So that means that your final is actually instead of 1.5 hours, it's going to be 2 hours. So your final is actually going to be it's 2 hours long now instead of 1.5. So that means that you guys have a little bit more time to do your finals. So your finals in this case will be 12:30 to 2:30. So it's 2 hours finals. So you guys can spend some time on a bit more time on it instead of 1.5 hours. So your finals is 2 hours long. So the review is on the review final will be next week, and yes, it's going to be on Zoom, and yes, attendance is taken, and yes, I will post in D2L if you need help. And do not forget, as usual, your tests, I allowed you to have the front page, right? Remember? So you can have that. So make sure it's a front page paper, so not both sided, and I will check with you guys. Does anyone have, make sure you put this in your calendar, because your final is actually worth 35% of your overall grade. That means that if you get an A in the class, and if you didn't take my finals 2 weeks from Wednesday, you will fail my class. So I just want to point out to you that do not forget to take my finals here, which is very important. The format is similar to your midterm, which is the first 10 questions is multiple choice. And then you got like 4 to 5 open-ended questions. So it's the same format. So again, concentrate on the open-ended question first, because that is the one that costs the most points. The multiple choice is only worth 1 point each. So at least if you are running out of time, you can, give me your A, B, C, D, E. Anyone have any questions with your finals?
Will you be available during your office hour times?
You just need to set, I do have 4 classes. I'm teaching 4 classes, so I'm giving 4 finals. So okay. So you just need to send me a time. Yes, send me an email with your time, different times and different days. Like, don't just give me one time, one day. Just give me like 2, 3 different times and days, so I can, yes. If I'm free, I'm definitely gonna have one-on-one with you guys. Yep. So make sure you guys do that. Anyone have any more questions? It's going to be on the same Zoom link, which is this link that you guys in. So no special links. It's the same Zoom link. But you just need to come early instead of, do we have 12:30 is the class starts. Oh, you just need to stay late. Sorry, you just need to stay late. So 12:30 is where the class starts, ends at 2:30. So you just need to stay a little bit late. It's a 2 hours long finals. Anyone have any questions?
Yes, I do have one question. So the exam, the open-ended, is it going to be on each chapter?
Can you, I cannot hear you. Can you repeat?
Yeah, I said the open-ended question, is it going to be on each chapters, like 7,
yeah.
1 question,
oh, yes.
8,
there
1
are
question?
4, yes, there are 4 to 5 questions. Definitely each chapter will have one. Yeah.
So every chapter have just 1 question?
Sometimes 2.
Like the...
Yep. Sometimes it can be 2, because it's 4 to 5. So yep. So make sure you guys I will give you the review for the finals as usual. So make sure you study for that. So yeah, it will be, I can tell you that every single chapters will be involved in your open-ended questions. Yep. So study. All right, so we're gonna concentrate.
Okay.
We're gonna do on your homework now. I think the first homework that you guys have is 9.2 question 6, right? And then we'll do question 8 because there's a lot of students asking me that question. With 9.2. So this is talking about body temperatures for men and women. So they are so if you see this that I'm highlight here in blue here, that means that the assumption is you do not need to check your assumptions. Okay, your requirements. Okay, so if they have these assumptions coming up in your test, so you do not need to check the requirements. So that means that you just move on, okay, to doing like what you did over here. So the test wants us to test the claim. This is your claim that the man is higher than women. So which one is your statements, hypothesis statements in this case? A, B, C, or D?
C.
Higher means greater. So make sure it's one is equals, one is greater than. So this is C. And then next one we're gonna do here is you need to find a test statistics. So you need to do your stat crunch. So I'm opening my stat crunch here. So since this is given us the statistic, so we will go down to T-stats, 2 sample with summary. So since the question gives us a statistic, we're going to do this. And man will be the sample 1 because that's what the first sample. So the sample mean in this case is 97.62. Standard deviation is 0.97 and the sample size is 11. For the female is 97.48. 0.68 is the standard deviation and 59 is the sample size. We are doing the hypothesis testing here and we are doing greater because that is what the statement says. We want to do it for equal and greater. So you compute. So this will be your test statistics and your p-value. So your test statistic in this case, if you round in 2 decimal place, is 0.46. And then the p-value will be, what is the p-value? Let me see. The p-value is 0.3 in 3 decimal space, 328.328. And then you look at your alpha, your level of significance, and it's given us by 5% or 0.05. So 32.8, that 0.328 is definitely greater than 0.05. So we will fail to reject because the p-value is greater than your alpha. We fail to reject. Yep, and that is not sufficient. Yep. And don't forget, class, in your finals, it's not going to be multiple choice like this. Make sure you know how to write this statement out because you will have to write this statement out. So I can tell you right now in your finals, it's not going to be multiple choice like this. Okay. So now we're going to figure out your confidence interval. So this is very, very important because yes, Linda, I will give you the study guide. Yes, you will have a study guide review for your finals. So in order for us to do this, so make sure you remember what you do with your confidence level. So if you remember, let's say, let me go up all the way to chapter 9.1 here. This is what you guys did in 9.1. So remember, this is the important stuff that I told you to write on a piece of paper. So I don't know how many of you did it. So if you have a one-sided test, your confidence level is 1 minus 2 alpha. And if you have a two-sided test, your confidence level is 1 minus alpha. This is the one that I keep on writing down on here repeatedly. So, so I'm going to do it again. So Teresa and a lot of you guys, as I told you, you need to write this in your piece of paper. And if you don't do it, you're going to be in big trouble. So for one-sided test, the confidence level is 1 minus 2 alpha. For a two-sided test, the confidence level is 1 minus alpha. So this is super, super important. So if you go back here, are we having a one-sided or two-sided test in this case?
One-sided.
One-sided. So we're going to use this formula, and alpha in this case is 0.05. So can someone tell me what is the confidence level in this case if you substitute alpha as 0.05 to this formula? This is important. This is where a lot of students get wrong in part B. Anyone?
.9.
Yep, 0.9. So what you do here is you just need to go back to your options, go to your edit, because you get the all information. So you just need to just move down to confidence interval and change into 90%. And you will get yourself the lower and upper limit. So the lower limit is here. So you get negative 0.405. And the upper limit in this case is going to be 0.685. And then they were asking is, do the confidence interval support the conclusion in the hypothesis test? The answer is always yes, because it contains 0. So as I also mentioned again, there are 3 important things here, right? One is the confidence level. The second thing is this one. If you have a both minus, it means that it's significant difference. P1 or mu1 is less than mu2. Is that both plus? Greater than. If 1 minus 1 plus is includes 0, no significance. So this, if you look at your confidence interval, you find out that 1 is minus, 1 is plus. So that's the reason why that it does include 0. So that means that mu1 is equal to mu2. So that's the reason why that it will support what is going on in this case. That means that you will not have sufficient evidence to support this claim that this is greater than. So it's always, so I just want to point out to you that the confidence interval and the hypothesis testings always have the same conclusion. Okay. So that is how we do this question number 6. Number 8 is the one that is pretty weird one. The reason why I say weird is because that part of this is given us as a data and part of this is given us as a statistic. So actually you need to find the statistic for this, the medium one. So that means you have to find what is N1 is, what is X1 bar and S1, standard deviation and mean. So if you read this question, let me minimize that. This question is asking us to test the claim that it is higher. So higher is also greater. So our hypothesis statement is D. So in order for us to find the test statistics, so now I need to write something down here. So I do need to import this into StatCrunch just for the L1, the first one, the medium one. So you need to go to stat, summary stats, and column. This is what you guys did way back in chapter when you find the mean, median, mode, mid-range, standard deviation, all those things that you guys did. Back in chapter 3. So this is what you have to do is you go to summary stats column and you pick the var one and you hit compute and they will give you all the stuff that we need here. So you need to copy this down. So in this case, your N1 is 11. Your X1 bar, your mean in this case is, you cannot round this. So please do not round this to 90.3 You have to use back all the decimals, 90.363636. And then the standard deviation, which is this one, the 10.288564. So once you get this, then we can do our, we got statistic now. So we will go to your stats and then we go to your T-stats, we do the 2 sample and with summary. And this is your sample one. So the mean in this case is 90.363636. The standard deviation is 10.288564, and there are 11 data here. And for the other one, you just need to do this one. This is the other one. So the mean in this case is 87.924, and standard deviation is 10.011, and sample size is 11. And we are doing greater since that is our claim. And that will
How
be
do you get there again?
how you get what?
To that. You go to stats.
Yep, the same thing, stats, t-stats, to sample with summary.
Okay.
Yep, this is how where you go to get just like a normal 9.2 homework that you guys do. We don't use data because we don't have both data. So we just only have one. So that's why we use summary. So you do need to figure out the summary of this one. So that's why you need to go through and figure out all these goodies. And then once you, where's my, so this is your test statistic here and your p-value. And again, in your test, I do ask for this too. So your test statistic in this case is 0.56 in 2 decimal place. And your p-value in this case is 0.29 because the 6 is big enough to round the 9 become, so 0.290. And then you use your p-value again and your alpha. Your alpha is 0.01 and the p-value is 0.29. So this p-value is actually greater than your alpha. So again, we will fail to reject because this number is greater. So that is not sufficient. So evidence. And then to find a confidence interval, you just need to, again, use back the one-sided or two-sided that I have here. So this is also one-sided because we are doing greater than, so it's a one-sided test. But our alpha is not 5% or 0.05. Our alpha in this case is 0.01 because that's our significant levels. So what is your confidence level in this case if your alpha is 0.01? And this is one-sided. We are using this formula again.
0.99.
No.
0.98.
0.98. Yep. Because it's 2 times of it. So that's why it's not 99, it's 98%. So you just need to, then what you need to do here is you need to go back here and then go to your option, edit it. Same stuff, do not change this. You just need to change the confidence interval here and change to 98. And you will get your limits here. So then that will be your, just put this in there and then the rest is pretty much the same. So so try to work this on yourself here because it's pretty much the same as the rest of your 9.2. So again, 9.2 we are going over stat, t-stat, and to sample either with data or summary. Data is where they give us all the data. Summary means they give us the statistics. 9.3 we go in stat, t-stat, pair. So make sure you do the pair in this case when you do your 9.3. So 9.3 we got 2 questions. I think number 6 and number 8 also. So we are going through that. Close on my, I don't need all my. Okay, let's take a look at 9.3 here. Again, this 2 homework is due tonight. So, and yes, it's going to be in your finals for sure. So this is number 6. Research collected data for the number of hospitals from the motor vehicle crash between Friday the 6th and the Friday the 13th. Use a 0.05 to test the claim that the 13 days of a month falls on Friday. This is used to test a claim when the 13th day of a month falls on Friday. The number of hospital admissions from what are not affected. So this is are not affected. So are not affected means they are not equal or not the same. So in this case, your mu D will be the mean of the difference. Yes, this is the one. So okay, this is something I want to point to you guys again. If you guys are writing something on your, especially you bring it to the finals, right? I told you you can put one piece. There's a lot of things you're gonna put in this one little piece, one piece of paper here. The difference is if you look at these two, mean of the difference and difference between mean. If in the finals, if you see me using mean of the difference or mean difference or mean of the difference, that is 9.3. Okay, but if I use the difference between the mean, that is 9.2. So I want you guys all to, if you guys have a piece of paper or something else, please write this down because this is very important. A lot of students did not catch this, and they, especially with multiple choice, are tricky. So make sure you know if I use the word mean of the difference or mean difference, if I show it short format, that is for 9.3, where we do the two means that's dependent. If I use difference between the mean, that is 9.2, where it's the two means that's independent. So make sure you got this 9.3, this is 9.2. So make sure, yes, these are the keywords that you guys will be searching for if you doesn't know the difference between 9.2 and 9.3. So this is the one. Not affected. So that means that this is always equals to 0 and this is not equals to 0. So that is the effect, not affected in this case. The next thing we're going to talk about is you have to do the test statistic. So you guys need to go on and open this on the StatCrunch, import it to StatCrunch. Again, class, in your finals, you cannot import this into StatCrunch. You do have to type it out. Okay. So what you need to go here is you go to stat, go to T-stat, go to pair. So this is pair because it's a 9.3, it's a dependent. And then the first column is, if you see that it is it's always the Friday the 6th, always the first one. So the first column is always the 6th and the second column is the 13th. And then you just need to figure, yep, this is the same, equals to 0 and not equals to 0. Okay, and you hit compute. So the test statistic in this case is negative 2.671. This is your test statistic. Yes, class, make sure you do 671. I will ask this in your test also, test statistic and the p-value. So some students, they just give me the p-value and they will lose a point automatically. Oh, now they're asking for critical value. So how do you figure out critical value? There's no critical value here, I can tell you that. How do you figure out the critical value in this case is you have to refer back to chapter 8, okay? So that is in 8.1. So in 8.1, no, sorry, wrong class. Not in applied stats. In 8.1, there should be a table. And yes, you can get all these notes in D2L. That's why I would want you guys to so this is the one that the critical values here. This is what you guys need to do to know. And we are doing mean. So this is a mean here. And now you have to figure out, are we doing two left or right? So what we do here is, if you look at this question, we are doing not equals to. Not equals to is a two-sided test. So if you look at this, it is going to be a two-sided test, which is this one. So this is how you find a critical value. So it's you have to go to stat calculators T. So in your stat calculators T, So this is what we have. And then you had to figure out the degree of freedom. Usually the degree of freedom is given in the first one, which is here. So this is your degree of freedom, which is in this case is 5. Okay. And then you need to change this to greater than. And then alpha, what is my alpha? And then you have to take alpha over 2 on the right side. So you need to have alpha over 2. And what is my alpha in this case? 0.05. So that is my alpha. So you take 0.05 over 2. And your answer is this. This is your answer. So if you look at this, they got 2 choices. Because you have what we call as a 2-sided test, your answer will have plus and minuses. So that's why your answer will be B, not A. And they want how many decimal places? Let me see. They want 3 decimal places. So that will give us 2.571. So this is the 2.571 is a critical value. Usually in the test, I won't do this method, so I will ask for p-value. So I don't know why they do this. So if they use this method, so what is going on here is you have to, so this is the distribution. So the critical value that you find is here, negative 2.571 and positive 2.571. This is 0 in the middle. And if your test statistic falls inside this region, the shading region, we will reject the null hypothesis. If it's falling here, you will fail to reject. So you look at your test statistic, and your test statistic in this case is negative 2.671. This is your test statistic here. So where is it fall on this number line? Negative 2.671. Inside the shading or outside? Where do you use? Negative.
Inside.
Yep, it's inside. So it's inside here. So that means that we will reject your null hypothesis in this case. So what happens when you reject your null hypothesis? What is your conclusion? There is or there is not sufficient evidence?
There is.
So there is sufficient evidence to warrant rejection, that the claim have no effects. So so if there is sufficient evidence that the claim has no effects, means that hospital actually do not appear to be affected by it. So what is going on here means that people who think Friday the 13th is a bad luck day, so people have more accident. So this is actually is not true. Oh, sorry. Yeah, this is reject. I know this that is failed to reject, so there is a is that true? Let me see. So you are rejecting this. That means the difference is no.
There is no difference.
So yes, actually, is this one. So there is sufficient work. So actually that is based on this data, actually that the admission appeared to be affected by the day actually. So because we are rejecting this, we are taking this part. So that means that the difference is not the same. So
so in other words, for this question, they said there was going to be no difference between the days, but because there's
no difference between the days. So so yep. Yes, so this says there's no difference between the days, which
the
means
hypothesis.
Yep. So your hypothesis is saying that it is saying what? We don't
that there is no difference in number of crashes.
There is no difference
on either days.
Yep. And so what happens? So what is the claim says? It says that there is no difference between these days, because this is what we're saying. So that means that it is affected by the the hospital is, okay, let's do this. Usually I don't ask this. The way that this figure out is really not. So it being not affected.
Mhm.
And not affected means it's this one. Oh no, this one, this is saying no affected, sorry.
Mhm.
Because when they are equal to 0 means they are no affected. When they are not equal to 0, they are affected. Sorry about that. So this is no affected. This is affected. So since we reject the null hypothesis, so it is affected by
Mhm.
the case in this case. Okay. So
I have a question. I just think that I have the wrong worksheet for the critical value. Can you pull up just real quick so I can see which one you used?
this one.
Oh, okay. I do have I have the wrong one. I mean, I printed one, but I'm just gonna take a screenshot real quick.
Yep. And class, if you need anything from this class, say, you know what, can I get the notes for chapter 7? This one, can I get something else? Please email me because I can email it to you. So if you don't want to go into detail and look for it, you just say, you know, David, I know we talk about this critical value. Can you email me that notes? Yes, I will email it to you.
Can you look at number 2, 9.3?
I don't really have a lot of time going over, so we might need to stay. Who is asking that? Can you stay back after class? And we need to go over chapter 10 today. For this case, for question 8, they're asking for the confidence interval. So I think you just need to import this into your StatCrunch. And you just need to do your the paired one. The first one is a type 1, type 2. Usually the first one is this one. We are going for confidence interval, and they even give you the confidence level. So this will be the one. So I don't know what's the 30.5, 30.6 if you run into. So I don't know what's the problem on this one, 30.6 and 100.9. So Tapu, I don't know what's going on here. So this is the work that you do. And then I need to. So the difference here is 30. So if you have a positive, means that mu d is greater than 0. So the difference. So it does not include 0, and both of those are positive. So it's either this. So what is the claim? I didn't read the claim here. Type 1 is better than type 2. Yep. So it is true that if you have a mu d, means type 1 is, so there is sufficient support to his statement because both of these are positive. So these are pretty much, this is not tough. If you're asking for question 2, see if I have time. I think we did question 2. We didn't finish it. I think I did question 2 last time. So is that Lutasha? You asked me question 2?
No.
No, it's me. It's Joy.
Okay, Joy, can we talk about after class? We did this actually last week, a little bit. Not, I didn't finish it.
Okay, I'll look at the video
It's
again.
the same, yeah, it's the same thing that you do to find a difference here. If you need, just stay after class because today we need to go on over chapter 10.
All right.
Yep. So that's the last chapter we're gonna go over. Otherwise, we don't have time. I hate to rush. You know what I'm saying? Chapter 10 in this case is talking about correlation and regression. So this is chapter 10. So what we did last time in chapter 9 is talking about 2 proportion or 2 means. Now we want to figure out that if the two variables here is related to each other, that's called correlation. Okay. I need to figure out how you change this back to different colors. Anyone know how to change this back to is it right click? I want a different colors. So
You right click
I did right click.
on the page. Maybe?
It's fine. I'll figure it out. It's not in the menu bar, so I don't know how. I want to change it to a different color. Maybe
Oh, the highlight. That would be the highlight. That's the middle.
Oh, there
one.
you go.
Oh, there it is.
There you go. Okay. So so what is going on is in this chapter 10 here, this is where we will do what we call as a pair sample data. What's the meaning when I say a pair sample data? It means that your data is been paired, means you have one person that give us two information, which is X and Y. For example, if I can ask you guys to give me your height and your weight. So that's called pair sample, means a person give me, every person here give me your height and your weight, or I ask for age and shoe size or something else like that. So if I ask two things and you give it to me, and that will call a pair sample or bivariate data. And if you give me that, then we will want to see if there's a correlation between these two variables. So what I mean by correlation means association or relation. For example, we know that your shoe size and your ACT score has no relation at all, right? Because doesn't matter. I mean, doesn't mean that you have a bigger shoe size, you are smarter, or a smaller shoe size, you are not smart. So we don't have that. So but height and weight, there is a correlation. We always know that. The taller the person is, usually the heavier the person is, because that is mostly that's correlation. So so there is also what we call as a linear correlation. Linear correlation means it's a correlation that have a straight line. So what is a linear correlation? A linear correlation is something that you have this is what we call a scatter plot, and those are your data. So if you remember when you do your algebra, you can, if you give me, oh, you are weight 50 pounds and you are like not 50, 150 pounds and you're like 5'8". So here is your data, your point here. So this is what we call as a linear correlation, means you give you guys a straight line. Okay. So so when you guys do a correlations, so there are two things usually we want you guys to do is you have to draw a scatter plot. Okay. This scatter plot tells us, do you have a straight line or not? Okay. So if your scatter plot looks something like this, yes, it is linear. If your scatter plot shows something like this, where the lines is a little bit, your dot is a little bit scattered, this is also shows linear. If you have, they are all pretty scattered, like literally really scattered, this is also called linear. So all these scatter plot that I just plot here, they shows linearity. Which one does not shows linearity is the scatter plot give you a parabola. So if you graph a scatter plot and it gives you a parabola like this is not linear. Or you get curve. So you got curve like this. We call it exponent or exponential. So this is not linear. So anything that is a parabola or something curvy like this is not linear. But if you see a straight line, although it's very scattered like this, it's considered linear. So these are all linear scatter plot, and the one in the blue is not linear. Okay. If your scatter plot came out like this, not linear, you do not need to do anything in chapter 10, because the entire chapter 10 that you study here is all about linear, which is this scatter plot. So if you do something like this, you just tell me that this is not linear. And that's nothing you can do with this. There are something you can do, but it's not in this class. You have to go take another statistic class to just study the nonlinear case. So, so that is what we'll do here. You have to draw a scatter plot. And scatter plots show us positive, negative, null, and nonlinear. So what happens to positive is your slope. So if you remember back in your algebra class, if your line goes up, this is actually positive. Okay. If your line goes down, then this is negative. So it's a slope that we're talking about. If you got scattered like this is no. Okay, no linear. So it's not the same thing as not linear here. So this is no correlation. Okay, and this is negative correlation. This is positive correlation. This is no correlation. And this will be the nonlinear case. So a scatter plot can tell positive, negative, no, and the non-linear case, like what we have the blue one. Okay. So the linear correlation coefficient is denoted by R. So you see that we use a lot of R in this case, and this R is meaning of correlation coefficient. So it will tell us the strength, and it also tell us are they positive, negative, or no. And this is called R in this case is called sample statistic. So for a population parameter is called rho. This rho I cannot. It actually looks something like a P. Okay, so this is rho. It's Greek, which stands for P. So it looks like a P in this case. Okay, so this looks like a P in this case, like a cursive P. Okay, so it's not P, it's the rho. So you guys remember when we talk about mean, we got two types of mean. I don't want. We got two types of mean. One mean is sample mean, X bar, and one is a population mean, mu. So this is also have two types. One is sample statistic R, which is a correlation coefficient, and the rho is a population parameter for correlation coefficient. So we got also one for statistic sample and one for population. What are the properties you have for this correlation coefficient? Your R is always between -1 and 1. So your R cannot be at more than, it can be 1, it can be -1, but it cannot be more than 1, it cannot be less than -1. And then I will show you what is the meaning of all this. What is 1 and -1 means. If you convert into a different scale, for example, I ask you for your height and weight, you give me inches and pounds, but I want to convert them to kilograms and meters. If I find the R, your R will not change. So what is going on is if your correlation coefficient for inches and pound is 0.3, and if I convert into different scale, your R is still 0.3. If I interchange all the X and Y values, your R is also not affected. So what is going on in this case, if your X is height and your Y is weight, let's say your R is 0.3. If I interchange it, X and Y swap around, then your R is still going to be 0.3. Okay. R measure the strength, and R is sensitive to outliers. So when I talk about strength, we have a few strengths here. We have a perfect, we have strong, we have moderate, and we have no. So there are 5 different strengths here. So what do I mean by if you have a perfect strength? Okay, a perfect strength is where all your dots line up to be exactly the same align, which is very rare. You will not get this in my data. So if you have this, this is what we call as a perfect strength. Means that it is nice or straight line. If they are very close like this, this is what we call as strong. Okay, because they are very close. This is also called as strong because the dots are very close. This dot is a little bit, you can still tell it's going up, but it's a little bit far apart. This is called moderate. Okay, this is no because they are really, so the weak one you can still see a little bit, but it's this is considered no in this case. So how do you usually we can tell they are perfect? Perfect means that your correlation is exactly 1 or -1. So if you got exactly 1, it's called perfect. For a strong, your correlation is between 0.9 and 0.7. So if you find that your correlation is between these two numbers, 0.7, 0.8, 0.9, 0.99, then it will be strong. Moderate is between 0.4 to 0.69. So if you're if you got around 0.4 to 0.69 is moderate. Weak is where you get around 0.1 till 0.39. And if you get
Oh, sorry. Are those that like those numbers don't change? Are they fixed?
It's kind of fixed, but it's not necessary. So if you got a
okay.
I mean, it's not like for sure. It's so if you got 0.69, some people still consider it as strong. You know what I mean? But if you bought 0.5 and 0.5, 0.4, 0.53, then it's considered moderate. So so it's not necessarily fixed this number, but it's very close. You know what I'm saying? And if you get very close to 0.1 or less, this is considered no. If your correlation is between 0 and so again, as what Cecilia asked, is this number fixed? Not necessarily. It depends on the person that think about it. So like my professor think 0.69 is actually pretty strong compared to, but you know, I put 0.69 here is moderate. But so, you know, when you're by the fence, you can always do, and so my professor says that if you got 0.69, just put these two together. They are moderately strong. You know what I'm saying? Because they are right in the fence on between strong and moderate. So, you know, so they say right in the fence. So you just combine those two together. That's what he says. So I said, okay, good. So yep, just use that. And I'm not that picky about it. So, and usually I give it very clear. Either I give you like a 0.9 or I give you a 0.5 or I give you a 0.2, you know. So it's very obvious that either strong, moderate, or weak. So I wouldn't give you like, you know, halfway there. So this is what we call as the strength of it. Okay. The requirements, it has to be 2. So this needs to be 2 a pair, and it has to be simple random sample, and it has to be quantitative. So a lot of students think that there is a correlation between, let's say, gender and IQ score. This is no good. The reason why this is no good is because gender is not quantitative. Gender is female or male. Gender here is categorical variables. So that's the reason why that you cannot say there's a correlation between gender and IQ score. It's because correlation only work for both quantitative variable. So you cannot use the word, you cannot have any categorical variables here. So this is no good in this case. So that is one of the requirements you need to watch out. Make sure that both of them are quantitative. The next one is you have to draw the scatter plot to confirm straight line or linearity, we call it. And if you have any outliers, we have to remove it, okay? Because outliers is sensitive, are sensitive outliers. So what is considered outliers? So we got a lot, we got different types of outliers here. So let's say that this is our data. You do a scatter plot. Outliers will be something that is inside this range, but is way out or way down. So this blue dot is what we call as outliers. And then if you have these black dots, this black dots is even further away from the normal group of data, but it's either way down here or way up, but that will change the whole line. This black dot is called influential points. And influential point is the worst enemy of regression here that we learned here. So if you have influential point, for sure you have to study it. Say why there is a dot over here or why there is a dot over here. You have to study what happens here, and you might need to redo the whole thing again because of these influential points. For outliers, you can usually just remove it. Okay, but for influential points, you have to study what's going on here. So there are some cases that in the real world that they found some influential points. They have to figure out what's going on. So if you read the textbook, they will tell you what's going on, the cases that we have. But outliers, we can always remove them, not a problem. But influential points is a problem. Yep. So so those are the requirements. So mostly the requirements more important on quantitative variable, and the scatter plot has to be straight line. Next thing is a lot of people think correlations implies causality. What does that mean when I say correlation implies causality? They use the big keyword cause. They will say that, let's say your test score and your attendance. So a lot of people think if you come to class a lot, your test score will goes up. So attendance in a class will cause the test score to goes up. So if you come to class a lot, so this is also no good, no. And the reason why is because you cannot just think about one variable that caused the other variable to happen. The reason why is because there are some what we call as the lurking variables that we did not mention. And what are lurking variables? Lurking variables in this case is the variables that we did not include in the study. So can someone tell me what are the factors that will cause your test score to goes up besides attendance?
Tutoring.
So tutoring time. So how much time do you spend on tutoring? Anyone? Don't forget, it must be quantitative. Sleep time, homework score. So those are, I mean, there's a lot of other factors that will cause your test score to goes up, right? How much time you study, right? How much time. So those are what we call as lurking variables, because these are the variables that we did not study in this case, and this will actually affect your test score. So that's why you cannot use the word correlation implies causality here, because there are some other variables that we did not study that actually cause something to the variable to change. So so that's big keyword here is the word cause here. And then the next thing that we talk about for error is if you have not linear correlations, do not figure out any correlations at all. So your StatCrunch is just, I mean, if you got something like this case, your StatCrunch will still going to give you the correlation, okay? Because the StatCrunch is like your calculator, right? If you just tell them what to do, they will just perform it for you. They don't understand what is going on, with this. So what is this second error here is if you find yourself having not a linear correlation, if you find yourself having a non-linear case like this case, no matter what R you find is useless. Okay, so you can still find the correlation for the nonlinear case is useless. Okay, that's what it means by the second error here. So that means that your StatCrunch will do whatever you tell them to do, but make sure you us as a human, we are a bit smarter than the computer. We actually know what's going on. So if you see anything that is non-linear case, stop. Don't need to do anything. Just tell me it's not linear. Okay. How do we test for linear correlation? So we are only testing, usually remember when you do hypothesis testing, you do 7 steps. This one you only need to do 2 steps. One is to write your hypothesis. Again, this is the row symbol the P symbol that I tried to type just now. So which is a population parameter. So the row is equal to 0 means there's no correlation. and rho is not equal to 0, that is a correlation. So in this case, we are just only doing equal and not equal. We don't do less than and greater than. And as usual, when your p-value is less than alpha, that is a linear correlation. You reject the null hypothesis. P-value is greater than alpha, that is not a linear correlation. And again, if you have not a linear correlation, make sure you stop, because chapter 10 will not able to do here. Okay. Don't tell me my computer is giving me that icky stuff again. Uh-oh. Yep, something happens to my computer. I can tell you that. It's my second time having this issue. Sorry about that. My computer is having issues. So good. They still remembered it, except for this one. So anyone have any questions for me with correlations in this case?
I just have one quick question. For the requirements, for number 2, when it says straight line, you drew several ones that were kind of like all over. That wouldn't be a straight line, right? Like the second one.
Everything on top here is considered straight line, including including this one.
Why is that considered a straight line?
We call it correlation. So this is considered no correlation. So the straight line can be going down like this. It's still a straight line. So it's a horizontal.
And it can be going up.
This is it'll be going like
Okay.
So it can be a straight line. So it can be going flat like this. It's still a straight line. But this you can tell they're not straight line.
Like a parabola wall.
You're correct. So that's why they are all still considered straight line in all these cases.
Okay.
So this is the same thing that we just. Now the next, so I'm going to combine 10.1 and 10.2. So 10.2 is actually doing what we call as regression equation. So when you do your homework, 10.1 is talking about correlation and how to test it. 10.2 is talking about regression equation. What is regression equation? Regression equation is like y equals to mx plus b that you guys learned in your algebra. But instead of using y equals to mx plus b, we use y hat. This is called y hat. This is called y hat. So it's like a hat. What is y hat? Y hat is called the predicted variable. So last time in your algebra, we used y equals to mx plus b. The y in this case is not predicted. Y in this case is actual. So the y equals to mx plus b that you guys did last time, the y in this case is what we call as an actual variable. Okay, and because you got so many dots in here, the line that I draw here is just what we call as a predicted line or estimation line, means it's kind of somewhere there. We just draw it out like that. So when you do that, so that's why the difference between those two is just we use y hat, and this one we use the y variable. So we don't do the y equals to mx plus b in this case. We use this symbol. Again, if you remember, the variable next to your x is your slope. So in this case, b1 is your slope. Then the b plus b is a y-intercept. So b0 in this case is your y-intercept. So this is back to your normal algebra class that you learned here. So we are doing slope and y-intercept. So finding this is all using StatCrunch. Do not use the formula, because the formula, if you look at it, you will cry. I will tell you right away. It's very difficult. We got a lot of names for these regression equations. We got regression line, line of best fit, least square line. So these are all the names for regression equations. So in my finals, sometimes I say, I want you to find the line of best fit or least square line, means you're looking for this equation. Okay. X is called an explanatory variable or predicted variable or independent variable. Y hat is called a response or the dependent variable. So this is just an extra stuff that just throw it out there. So if you guys need to figure out what is explanatory and what's response, that's your x and y hat. Again, we don't use y, we use y hat here. Every time when you make a regression, so let's say we got a line here, and let's say this line is y hat, forget the hat, equals to, let's say the slope is 2x plus 1. Okay, so this is your equation. Usually it's full with decimals, but I'm just making it easier. Usually what is the purpose of us doing this is we try to make prediction. What is prediction here is I want to predict someone who are here, which is 8. And I try to predict this value. What is this value? And how do I make prediction is usually I plug 8 inside my x. Then figure out what is this y hat here. So that will be 17. 2 times 8 plus 1. Okay. So that's meaning of prediction. So that is a main reason why you guys need to learn this regression line is to make prediction. And usually how we make prediction is we substitute. Okay, we substitute the x value into the regression equation, and then figure out what is the y hat. However, in order for you to make the prediction, you're not simply just put the x over there, you know, and then figure out using your calculators. You have to go through these 3 important requirement. One, the scatter plot has to show straight line. Next, it has a linear correlation, and there will be your data do not go beyond your scope, means no extrapolation. I will explain to you what all this means. So the first thing is that in order for you to pass the first one, your scatter plot should be show linearity. So what does that mean is when you plot out your scatter plot, your StatCrunch will do it. You have to be one of these things on top, okay, not showing curvy like this. Okay, so that is the first rule, is show linearity. Second thing is that your R indicates showing linear correlation. This is way back over here. So in order for us to have a linear correlation, your p-value should be less than alpha. So what you need to do in this case is you just need to check your p-value has to be less than or equal to alpha. So these are the 2. So you have to check those 2. And the last one is extrapolation. And what is the meaning? Extrapolation means that you try not to predict far away from your data. So what is extrapolation? So remember last time I predict 8 here, right? 8 is not extrapolation because 8 is very close to the data. In order for me to have extrapolation, I will try to predict 100. That means you try to make a prediction that is far away from the rest of the group. That is the meaning of extrapolation. So like examples like temperature, we can predict the temperature tomorrow, the next day, the following week. That is not extrapolation. But if you try to predict the temperature in 4 months based on what we have, that is considered extrapolation, means you try to make a prediction that is really, really far away from the rest of, from the data that you have. So, so if you have such thing, means it's no good, okay? So we try to have no extrapolation. We try not to predict something that is far away from the data that you have. Okay. Usually, it's very obvious. Either I want you to predict like 8, like what you have over here, or I want you to predict 100. So if you have such thing, this is considered extrapolation. Okay. So if you fulfill all these 3 conditions, then you will consider good model. That means you fulfill all these 3 conditions. Then you can substitute the x into the y, the equation, the y hat, and then figure out using your calculator. However, if you got not a good model means you did not satisfy one of these conditions, then you will find the sample mean y bar. So in StatCrunch, you just need to do the summary stat column. Remember last we did it in today's class. We find the, and then make sure you pick the y variables. Okay. So that is what I will show you. If your scatter plot shows not a linear line, means the first one, then you have to ignore everything. Okay, so if your scatter plot shows not a linear line, you cannot, the whole chapter 10, as I mentioned, is you cannot do anything on it. You cannot even do all these things. So how do your StatCrunch calculation work? You go to stat, regression, and simple linear. Okay, and usually they will give you the results will look something like this, y and x. Just make sure that this is something that is missing in your StatCrunch. Is it should be y hat here. Okay, so a lot in your StatCrunch they forget to put a little hat on it. So make sure when you guys do it in my test or your homework, make sure you have a hat on it. I don't know why they don't put a hat on it, don't ask me. And then they will look at this and they will give you the R, which is a coefficient. This is used in 10.1. And then the one that I highlight, this is your p-value. This is also used in 10.1 and 10.2. Remember, this is where you do your correlation coefficient. This is your test statistic. So if a question is asking for test statistic, this is a test statistic. The rest that I did not highlight is not important. So you will learn this in the next statistic class. But right now, the one that I highlight, this equation is called a regression line. This is 10.2. Oh my God. Yep, this is 10.2. The regression line is 10.2. The R is 10.1. And then the test statistic depends 10.1, 10.2. The p-value is 7. And then the whole table underneath it that we call it analysis of variance. You do not need to do this. So this is all, you don't need to worry about it. So these are the stuff, and I'll show it to you in your StatCrunch where it is. So you go under stat, you go under regression, and you go under simple linear. And then make sure, usually the first one is your X and the second one is your Y. And then you just keep this like this. You don't change anything. And you didn't do the confidence interval, and then you hit, let me see, yep, and you hit compute, and they will give you this. So that is your regression equation. This is your correlation coefficient, R, and then make it bigger here. This is your p-value. And then if you see the little arrow here, so if you go click on the next arrow, this is your scatter plot. So you see a little arrow here. So that is a scatter plot. So you can tell this is pretty linear here because that's a straight line. So this is, so you make sure you go on to the next to see your scatter plot here. So this is what it looks like in your, in this correlation in this case. You guys all right here? Okay, we'll look at some homework here. So you guys will get, so 10.1 and 10.2 is due on next week, next Wednesday. So make sure you guys got this down. So mostly the first few questions is asking us about this one you probably have to read through it. It's pretty much the word cost. This is the one keyword that you don't want. So the answer will be no, because you cannot say cost here. Okay. Now this is the one that you will get. So I give you 5 scatter plot, and they give you 5 numbers. So can someone tell me what is this scatter plot number 1 looks like? What is a correlation here?
-1.
Because it's a straight line going down, so this is a -1. This one, you know, is also going down. You can tell the line is going down. So which one of this is work for him? Is that
-0.721.
is that I'm gonna go slow here. Is that strong, moderate, or weak? This is pretty moderate, so that's why it is -0.721. What happens? Go bigger on this one. Yep. This one you can tell is going down, but the dot's a bit further away. So anyone guess what is this gonna be for scatter plot 3? Anyone? Beside Linda?
Point-
No condition.
Which one?
0.712.
Points.
Oh,
No, 0.71.
Sorry, it's -0.37 because it's going down, right?
Yep. So this is -0.37 because it's going down and it's very scattered. You can tell it's a bit scattered. This one is really nice straight line, but there are some dots that are not in the straight line. So that means it's pretty strong, negative. So your answer will be which one? That five first.
-0.996.
6. Yep. And this one you can tell the lines go up. So that means your is positive. So it will be 0.721. You guys all right here? So you will get something like this in your finals, where I give you like this question, scatter plot number 2. I give you A, B, C, D, E. So which correlation goes with this one? You know what I'm saying? So this is the type of questions you have. Now, the next one I want you to do here is to, this is the scatter plot, X and Y, and they want you to do a scatter plot. So what you need to do is import it to StatCrunch, open to StatCrunch. Okay, go to Stat, go to Regression, Simple Linear. This is where you go for chapter 10. And make sure the first one is X, the second one is Y. So if they give you XY, you just pick XY. And once you pick these two, you just hit compute. And if you want to see the scatter plot, you just need to hit the second side. So the blue dots is the scatter plot. So can someone tell me which one is the scatter plot in this case? A, B, C, or D? Yeah. I'm going to take attendance, so please do type in present.
It's C.
It's C in this case, so we kind of curve in this case. Okay. And then the next question is asking us to find the correlation coefficient. So this is in your scatter plot here. You just go back one more. So R here, do you see the correlation coefficient? This is your answer here. They want 3 decimal place. So it's 0.815. So this is your correlation. And then they're asking us, do we have a sufficient evidence? So what we do here is we look at your p-value. So your p-value is this 0.002, and your alpha is what, 0.05. Is this number less than or greater than alpha? Again, we are looking for this number, not the top one. Less than, so what do you do if it's less than? There is, or you reject, right?
Reject.
And there is or there is not sufficient.
There is.
So so we're gonna say that is sufficient for a linear we don't do non-linear here. Again, this is not in chapter 10. So we always do linear correlation. So this is the answer here. So it's very similar to what you guys did here. Now, this is something that I want to point. This is something that what you will be missed if you do this without constructing the scatter plot. Can someone tell me, is this scatter plot linear or non-linearity? Non-linear. But guess what? Your StatCrunch still provide you R, and it still say it's a linear correlation when you guys do in your, see that? You still say it's linear correlation, but actually the scatter plot reveal that this is a not straight pattern. Okay. So if it's not a straight pattern, do you need to do this R and this linear correlation, this thing?
No.
No, you don't. So that's why a lot of students just go straight here without doing the scatter plot. And that's why no good. The next one is the same thing, just copy and paste. And this one, I think you might have in outliers, I think they call it. Now this is special. So this questions is where you need to type in your data because the data did not give us, they don't have any data, okay? So how do you do your data here? So you need to type in your data here. So I'm gonna get rid of all this. So you need to know your coordinates. There are 10 points here, so you need to know. So let's start with this. Let's start with this point. Can someone tell me what is your coordinates for this point?
1,
X is 1, Y is
1.
1. So you have to type 1, 1. Then let's go up. Can someone tell me what is the coordinates of this point?
1, 2.
1, 2. And then the up this point?
1, 3.
1, 3. So you actually have to type this out. That's not, you cannot import. And then how about this point next to it?
2, 2.
2, 1.
Or 2, 1, sorry, yeah.
Fine. And then the one above it is 2, 2. And then 2, 3, right? So this 2, 1, 2, 2, 2, 3. How about this one?
3, 1.
3, 1. And then 3, 2. And then 3, 3, right? And then we got one more, which is right over here. This is 10 what?
9.
10, 9 or 10 here?
9.
9, yep. So you actually, this one, literally you have to read it like this. You have to type it in. So make sure you know your coordinates and then you go to stat, you go to regression and simple linear regression. And same thing, X is X, Y is Y. And then you compute. So this is your correlation here. So the question asking is, do we have a strong correlation?
Yes.
Because it's 0.9, so it's pretty strong. Yep. What is the correlation in this case? The one I just showed to you here in 3 decimal place, 0.893. Okay. And then they will ask you, is there a linear correlation? So again, we look at your p-value. Class, look at the bottom one, don't look at the top one. Some students look at the top one, they get it wrong. Make sure you look at the bottom one. Or if you're scared, look at this one, because I can tell you this two has to be the same. See these two, the p-value? They all have the same. So make sure you look at the bottom one, don't look at the top one. So is this number less than or greater than this alpha?
Greater than.
0.0005.
Less than.
Is
Oh.
less than. So is that a call? If it's less than, we what, reject or fail to reject? We reject, right?
Yeah.
So there is a linear correlation. So that means yes. Is that linear correlation? Yes, because you reject, so it has to be in the critical region. I don't want to use the critical region, but and what else? Now, what they want you to do is you have to exclude 10, 9, the coordinate 10, 9. So what you do in your in here is you X it up, and now you take the 10, you delete this point out. So this is no 10, 9. So now you have 9 points here, and you go to your same thing, stats, regression, and simple linear, and do the XY. You repeat the same thing. And what is your correlation coefficient now if you exclude that point? It is 0. So what happened is that your point that 10, 9 is a big, it's actually is a, we call it an influential point, because now you only have these 3 square dots, these three dots here.
How do you know if it's influential or if it's like an outlier?
Influential is where you get all this out here. This is called influential. Outlier, that means they are way out. This is where the data at, right? It's between, let's say, 5 and 20. So outlier is where you have points going up and down like this on the same area. This is outliers. These are
So
called
influential is just farther apart.
Oh, yeah. Further away. Yep. Yep. So with these questions, they will ask, what is my same thing. You just need to look at your p-value, and your p-value this time is exactly 1. Is this one is less than or greater than alpha? Greater. So that means that that is not a linear correlation because it is not in the critical region. And they will ask you, what can you conclude with this? Do this 10, 9 change, or does it not change? This 1.109, this point,
Yes, it
changed a lot, right? It changed from 0.98, almost 0.9 to 0. So yes, this is change. So yeah, that is, so if they change significantly like this, we call it as an influential point. The rest looks the same. You just copy and paste this and then do the scatter plot. So mostly what they do in 10.1 is asking for scatter plot, correlation, and then figure out if they are linear or not linear, and then they want you to take a point out and do something like that. But when you do 10.2 is asking kind of the same thing, but this time they're asking for the regression. Okay, so now if you see the B0 and B1, this is sample statistic. If you look beta, this is called population. So the first one is for sample, second one is population. I think I mentioned to you guys that for sample, we always use A, B, C, D. For population, we always use Greek, like alpha, beta, mu, all those weird Greek letters. So that is the one that we guys are going to do. Let me show you. This one I need to spend some time on it, but let me show you the other one. Yep, this is okay. So like this one, you just again copy and paste this into your StatCrunch. This one they want you to write in an equation the head. So the same thing, you go to stat, you go to regression, simple linear, and x is x and y, and then you hit compute. Same thing like what we just did just now. So now, last time we looked at regression, now we look at this one. So this is your linear equation here. So you just need to, in 2 decimal place, this is 2.5 plus 0.6. So this is 2.5 and 0.6x. So it's very, so you're just looking at a different type, and then they want you to look at your scatter plot. So you just need to go on to the next page here, and you will get yourself a scatter plot coming up. And again, this scatter plot is a curve like this, which is this one. Okay. And then what they want you to do, yep, this D, yep, curve. And then what happens is because it's a scatter plot, it's a curve, so actually the data is not a straight line. This is very similar to what we just did just now. So actually, again, it's not straight line, so everything what you do here is redundant, okay, because this is not straight line. Mostly the rest are all asking for the same thing, you just do the scatter plot, but this time, let me see one of them. This is the same thing, class. Make sure you know how to put in your coordinates, like what I just teach you just now. Then you will get a regression line. And then after that, they ask you to remove 7,1, which is this point, and see what happens. The line is going to go flat, I can tell you that, because those are pretty weak. Now, this is the one I want to go through with you guys. It's doing prediction here. So again, we open this in StatCrunch, and then we do the stat regression simple. Now, a lot of students ask me which one is my X, which one is my Y. I want to tell you that always the first one is your X, the second is your Y, always. Okay, so the first chest is X, weight in this case is Y. And when you hit and compute, so this is your, so they put it in a weird way, but this is your equation here. So it will be 227.1. So this is 227.1 in one decimal place. And the other one is 11.9 in one decimal place. This is your slope. Okay. Don't forget the number next to your X is your slope. And the 227.1 is your Y-intercept. Do I type something wrong?
We didn't put the negative. It's supposed to be minus.
Oh, that's a
2.
negative. Thank you. I didn't see the negative. Thank you so much. Yep, that is a negative. Cannot. Again, make sure you make your B. Yep. Now we want to make prediction. Now, do not forget that in your test, in the prediction, a lot of students just, oh, let's plug 50 inside here and then use my calculator to figure out what is this. No, you cannot do that. You have to actually go through the 3. Remember the 3 things you need to do. So in the test, you do need to do all these 3 things. So the first thing you need to do, class, is to tell me. So this is what you have in the test. First thing is you have to tell me is your your scatter plot shows linearity. So what you need to do here is you, oh shoot, why I X it out? Sorry about that. I X the whole thing out. This one's gonna be. So you look at this. So is this dot shows linear?
Yes.
Yes. So this dot shows
Yes.
linear. Yeah, because it's a straight line. And B, your p-value has to be less than or equal to alpha. So what you need to do is, because that shows linear. So p-value in this case is 0.001, right? And what is alpha in this case? It's gonna be somewhere here. Alpha is 0.05. Is your p-value less than alpha here? Yes.
Yes.
This number is that. So that means this means it shows linear correlation. Okay. And C, you can no extrapolation. What is no extrapolation in this case is you look back at your scatter plot. 50 is trying to predict 50, right? Is 50 on this line on around here? 50 is here, right?
Yes.
So that means there is no extrapolation. So in order for us to have extrapolation, you try to predict 200 or 150, you know what I'm saying? That is considered extrapolation, where you try to predict something that's far away, or you try to predict something that's little, like 10 or 5, you know what I mean? So it can be on the left or can be right. So when they're predicting really far away from, that's called extrapolation. So since these 3 are good, so it's good model, we say this is good model. And what happens when you have good model, you can actually what? Substitute this 50 inside this. So negative 227.1 plus 11.9 times 50. So you can take out this one, you need calculators. So now we can substitute back in there. So 11.9 times 50 subtracted by 227.1. So your answer is 367.9. And then you look at the actual. The actual weight is 427. Is this close or is this far?
Far.
Far. So this is not very close, right? To the actual weight. This is far. So this is what happens if the models is correct. Now what happens if one of these is no good? then this will give you what? A bad model. And in order for you to do this, you cannot do like what you have here. For bad models, you have to find the sample mean for Y. So how do you do that in your StatCrunch is you go to here. Don't forget, this is your Y. So you go to stat, go to summary stat, go to column. And then you pick weight, because that is the Y value. And the mean here is almost 400, 399.17. So if you have a bad model, this is what you do. Okay, but since it's a good model, so we're gonna pick this one. Let's see if I can get to a bad model here. So in this one, we're gonna find the regression equation. So again, right is X, left is Y. Regression, simple linear regression, right and left, compute. So again, this is your equation here. So it's 49.6 plus 1.2. 49.6 and 1.2x. And then now you want to predict if 90 is, so instead of putting this, again, you have to go through the 3 steps, the 3 requirement. So let's take a look at our, you got this dot, this dot, this dot. Is this shows linearity? Anyone? You got
Yes.
this? Yes, again, linearity means not curvy. Okay, this is an outlier. See, this is outlier because these dots are pretty good. This is an outlier. So this still shows linearity. Don't forget, not linear means it's curvy line. Now let's take a look at your p-value in this case. Your p-value is 0.0768. And the the alpha in this case is what? 0.05. Is this p-value more than alpha or less than alpha?
Less.
0.0768 is.
Oh, sorry, I couldn't see it. It's more.
Is more. So that's why this is more. So guess what? This is no good. Okay, because it's more. We want it less. This is more. So this is bad model. What we have in this question is bad model because that's not a linear correlation. So what you need to do here is you cannot plug in 90 inside here. You have to find the mean. So in your StatCrunch, you just need to go to, where's my StatCrunch? Go to stats, go to summary stat, go to column. And don't forget, left arm is your Y, not the right arm, because the second one is the left arm. So compute, and the mean is what? 155.6. So that is your answer in this case. It will be 155.6. Okay. You guys all right here? Anyone?
Yeah.
This is not difficult actually. It's just new. This is the last chapter, I can tell you that. So make sure you guys do this because it will be coming up in your test, and make sure that when you do this, make sure you write these 3 out in your test, because in this test, this worth like 4 points just to figure this one out. Okay, so make sure you check your 3 requirements before you plug everything in or find is it good or bad model in this case. Okay. All right, so, so I'm gonna stop sharing here. So you got 2 homeworks due tonight and then 2 more homeworks due on Wednesday. We will have a last Zoom meeting next week before your finals on the following week. If you do have questions, you may stay. If you don't have questions, you may go. I'm going to stop recording here. And this is the last one.